The big mystery of the Big Bang. If no one was around to hear or see the Big Bang that started the universe, how do scientists know what happened more than 13 billion years ago? Like detectives reconstructing a scene they did not witness firsthand, these scientists use tools to search for and analyze clues that they find. Using an advanced telescope in 1919, Edwin Hubble shook up the world of astronomy. He was the first astronomer to observe other galaxies beyond Earth's Milky Way. Not only that, Hubble noticed that all galaxies in space were rapidly moving away from one another. That is what happens after something explodes or expands. Hubble's discovery of an expanding universe, tested and proven many times since, laid the foundation of the Big Bang Theory. Astronomers also use other tools to test theories about the Big Bang. Objects in space have individual characteristics such as different lengths, colors, and chemical compositions. Scientists study these characteristics to identify the age, size, location, and composition of objects in space. Spectroscopes measure light waves, and spectrographs measure the chemical properties of objects in space. In 1965, two astronomers designed a special radiometer. This led to the discovery that background microwave radiation was spreading throughout the universe. Most astronomers had theorized that if the Big Bang set off a huge, hot expansion, there would be leftover radiation everywhere in space. This turned out to be the case. Arno Penzias and Robert Woodrow Wilson are the physicists who discovered that background radiation. They won the Nobel Prize for Physics in 1978 for their discovery. The snow or static you see on your television when a station signal drops is background radiation from the Big Bang. Indian astronomers using a telescope in Chile found support for their theory related to the Big Bang. Astronomers had predicted that older objects, which had formed right after the Big Bang, would be hotter than younger ones that formed later on. This, too, has turned out to be a fact. In 2008, astronomers observed one of the oldest galaxies ever formed in images the Hubble telescope sent back to Earth. The light from the galaxy took 13 billion years to reach Earth. The galaxy's light has the spectrum of chemical characteristics astronomers predicted objects would have if they formed shortly after the Big Bang. Some mysteries about the Big Bang remain to be tested. However, repeated tests have solved many other mysteries. Our solar system. More than 18 billion years after the Big Bang, 4.6 million years ago, the birth of our solar system took place within the universe. Experts believe that the solar system, with our sun at the center, probably developed in several stages. An event such as supernova caused a floating cloud of gases, dust, and ice in the spaces between stars to collapse. The collapse formed a spinning nebula made up of gases, space, dust, and ice, which fell into the center of a disk. A disk is a circular, flat area in space made up of dust and gas. The sun is a central star in our solar system. It makes life on Earth possible. Without sunlight, when sunlight hits someone lying on the beach, it has traveled 94.5 million miles, 152 kilometers, in just 8 minutes. Okay? Starting off from right here, it says, and may include stars. The collapse released energy, causing an early star to form and heat up at the center of the disk. The star would become the sun. As the sun formed, it pushed out gases and dust. This leftover pushed out matter-formed particles in the disk. Over time, collisions, gravity, and chemical changes took place within the disk. Material left over from the sun's formation clustered together at different times and in different chemical compositions or combinations. Okay. The sun developed into a hot star long before any planets formed around it. Its solar heat melted away ice from Mercury, Mars, Earth, and Venus, the rocky inner planets. Okay, I'll stop right there and we'll start off right here when I return.